The factory floor falls silent except for the rhythmic precision of mechanical fingers assembling components with surgical accuracy. This isn't science fiction anymore. This is the reality that's transforming manufacturing as we speak in 2025. OpenAI has just shattered every expectation with their revolutionary GPT-powered robotic hand system priced at an unbelievable $999. While competitors struggle with million-dollar solutions that require armies of engineers, this breakthrough makes advanced automation accessible to every manufacturer on Earth. The implications are staggering, and they're happening right now, reshaping entire industries overnight. Subscribe now, because what you're about to discover will change everything you thought you knew about manufacturing automation. Comment below if you've witnessed similar automation breakthroughs in your industry. The stories coming in are absolutely mind-blowing. This isn't just another tech announcement. This is the moment manufacturing entered a completely new era. The morning shift at Precision Manufacturing Solutions started like any other Tuesday in September 2025. Until production manager Sarah Chen witnessed something that would redefine her entire understanding of industrial automation. Standing on the factory floor, she watched in amazement as OpenAI's latest GPT-powered robotic hand system seamlessly integrated into their assembly line, performing complex tasks that had previously required highly skilled human workers. The $999 price tag seemed almost too good to be true, considering that similar robotic systems had cost upwards of $50,000 just months earlier. This wasn't simply a cost reduction. It was a complete paradigm shift that promised to solve the manufacturing crisis that had been plaguing industries worldwide since the supply chain disruptions of recent years. The technological breakthrough represented by OpenAI's GPT robot hand extends far beyond mere mechanical precision. Powered by the advanced reasoning capabilities of GPT-5, which launched in August 2025 with its groundbreaking 20 million token context window, these robotic systems demonstrate an unprecedented level of adaptability and learning capability. Unlike traditional industrial robots that require extensive programming for each specific task, the GPT-powered hand can understand natural language instructions, adapt to new scenarios in real time, and even troubleshoot problems independently. The integration of OpenAI's real-time API, which scored 30.5% on the multi-college audio benchmark compared to the previous model's 20.6%, enables these robotic hands to communicate effectively with human operators, creating a truly collaborative manufacturing environment that was previously unimaginable. Manufacturing facilities across North America and Europe are experiencing what industry experts are calling the Great Automation Acceleration, driven by the perfect storm of labor shortages, rising wage costs, and the urgent need to bring production closer to home markets. The geopolitical tensions and supply chain vulnerabilities exposed in recent years have created an enormous demand for nearshoring and reshoring manufacturing capabilities, but the economics simply didn't work with traditional automation solutions. OpenAI's $999 robotic hand system has suddenly made local production cost-effective, allowing manufacturers to compete directly with overseas facilities while maintaining the advantages of proximity to their markets. This shift is particularly evident in electronics assembly, where the precision requirements and small component handling had previously made automation prohibitively expensive for many manufacturers. The economic mathematics of manufacturing automation changed overnight when OpenAI announced their revolutionary pricing strategy. Where Goldman Sachs had projected humanoid robot costs to remain between $30,000 and $150,000 through 2024, OpenAI's breakthrough has compressed these figures dramatically. The $999 price point represents not just a reduction in hardware costs, but a fundamental reimagining of how robotic systems are designed, manufactured, and deployed. By leveraging cloud-based AI processing and standardized hardware components, OpenAI has achieved economies of scale that seemed impossible just months ago. The result is a democratization of advanced manufacturing capabilities that puts sophisticated automation within reach of small and medium-sized businesses that could never previously justify the investment in robotic systems. Integration challenges that had historically plagued manufacturing automation have virtually disappeared with OpenAI's approach to robotic deployment. Traditional industrial robots required months of custom programming, safety assessments, and workflow redesign, often costing more in implementation than the hardware itself. The GPT-powered robotic hand arrives as what industry insiders are calling a plug-and-play solution capable of learning existing manufacturing processes through observation and natural language instruction. Factory workers can literally show the robotic hand how to perform tasks, explain quality requirements in plain English, and watch as the system adapts and improves its performance in real time. This simplification of integration has reduced deployment timelines from months to days, fundamentally altering the cost-benefit analysis that had previously limited automation adoption to only the largest manufacturers. Quality control and precision manufacturing have reached new heights. With the implementation of OpenAI's vision-enabled robotic systems, the integration of advanced visual perception capabilities enhanced in GPT-5 allows these robotic hands to perform quality inspections with accuracy levels that surpass human capabilities. Components are measured, evaluated, and sorted with microscopic precision, while defects are identified and categorized automatically. The system's ability to learn from each quality issue means that manufacturing processes continuously improve, creating a feedback loop of enhancement that drives down defect rates and increases overall product quality. This capability is particularly revolutionary in industries like aerospace and medical device manufacturing, where precision requirements are extraordinarily demanding and traditional automation solutions have struggled to meet the exacting standards required. The human workforce impact of this automation revolution is proving more complex and nuanced than early predictions suggested. Rather than simply replacing human workers, the GPT-powered robotic hands are creating new categories of jobs and changing the nature of manufacturing work. Workers are transitioning from direct assembly roles to positions focused on system monitoring, quality assurance, and process optimization. The collaborative nature of these robotic systems means that human workers and robots are working side by side, with each contributing their unique strengths to the manufacturing process. Humans provide creativity, problem solving, and adaptability, while the robotic systems handle repetitive tasks, precise measurements, and hazardous operations. This symbiotic relationship is creating manufacturing environments that are both more productive and more engaging for human workers. Global supply chain dynamics are experiencing a seismic shift as manufacturers worldwide implement these affordable automation solutions. The traditional economic advantages of offshore manufacturing are being challenged as local production becomes increasingly cost competitive. Countries that had lost manufacturing capabilities to lower-wage regions are seeing a renaissance in industrial production, driven by the combination of automated efficiency and reduced transportation costs. The $999 robotic hand is enabling manufacturers to establish production facilities closer to their end markets, reducing lead times, improving responsiveness to customer demands, and creating more resilient supply chains. This trend is particularly pronounced in industries where transportation costs represent a significant portion of total product cost, such as furniture, appliances, and automotive components. Research and development cycles in manufacturing are accelerating dramatically as companies leverage the learning capabilities of GPT-powered robotic systems. Product prototyping, which previously required extensive retooling and setup changes, can now be accomplished through simple software updates and natural language instructions. The robotic hands can switch between different assembly configurations, test various component combinations, and provide detailed feedback on manufacturability and quality issues. This capability is compressing product development timelines and enabling manufacturers to respond more quickly to market demands and consumer preferences. The ability to rapidly prototype and test new products is creating competitive advantages that extend far beyond simple cost savings, positioning companies for success in increasingly dynamic markets. Environmental sustainability is emerging as an unexpected benefit of widespread robotic automation in manufacturing. The precision capabilities of GPT-powered robotic systems are reducing material waste, optimizing energy consumption, and improving overall resource efficiency. These robotic hands can work with tighter tolerances, reducing the amount of raw materials required for each product while simultaneously improving quality and durability. The systems can also operate continuously without the need for lighting, heating, or cooling required for human workers, significantly reducing the energy footprint of manufacturing operations. Additionally, the ability to quickly reconfigure production lines for different products reduces the need for multiple specialized facilities, further improving resource utilization and environmental impact. The competitive landscape of manufacturing is being completely rewritten as barriers to entry collapse and new players emerge in previously closed markets. Small companies that could never compete with large manufacturers due to automation cost barriers are suddenly able to achieve similar levels of efficiency and quality. This democratization of manufacturing capabilities is creating opportunities for innovation and competition that didn't exist just months ago. Startup companies are launching manufacturing operations that would have required massive capital investments in the past, while established companies are finding that their traditional competitive moats are being eroded by nimble competitors. Leveraging affordable automation, the result is a more dynamic and competitive manufacturing ecosystem that benefits consumers through improved products, lower costs, and greater innovation. International trade patterns are shifting as the economics of global manufacturing change. Countries that built their economies on low-cost labor are finding themselves needing to adapt to a world where automation reduces the importance of wage differentials. Meanwhile, developed nations are seeing opportunities to rebuild their manufacturing sectors using advanced automation technologies. The $999 robotic hand is serving as a catalyst for this transformation, making it economically viable for companies to establish production facilities in their home markets rather than seeking the lowest labor costs globally. This shift has profound implications for economic development, trade relationships, and the future structure of the global economy. Investment patterns in manufacturing infrastructure are reflecting the new realities created by affordable automation. Venture capital and private equity firms are increasingly focused on companies that can leverage these new technologies to create competitive advantages. Traditional manufacturing companies are finding themselves needing to rapidly modernize or risk being displaced by more agile competitors. The relatively low cost of entry for advanced automation is enabling a wave of innovation and entrepreneurship in manufacturing that hasn't been seen since the early days of industrialization. This investment activity is creating a virtuous cycle of innovation as companies compete to develop even more advanced and cost-effective automation solutions. The skills requirements for manufacturing workers are evolving rapidly as automation becomes more prevalent. Educational institutions and training programs are scrambling to adapt their curricula to prepare workers for a manufacturing environment dominated by collaborative robotics and AI-powered systems. The new manufacturing workforce needs to be comfortable working with advanced technology, capable of training and managing robotic systems, and able to focus on higher value activities that complement automated production. This transformation of skill requirements is creating both challenges and opportunities, as workers who can adapt to the new environment find themselves in high demand, while those who cannot adapt may struggle to find relevant employment. Looking ahead to the remainder of 2025 and beyond, the trajectory of manufacturing automation suggests even more dramatic changes on the horizon. OpenAI's breakthrough with the $999 robotic hand appears to be just the beginning of a broader transformation that will touch every aspect of how products are designed, manufactured, and distributed. Industry analysts predict that the success of this initial offering will accelerate development of even more advanced and affordable automation solutions, creating a compound effect that will reshape the global economy. The manufacturing crisis that seemed intractable just months ago is rapidly giving way to a new era of abundance, efficiency, and innovation that promises to benefit businesses and consumers worldwide. The integration of artificial intelligence into manufacturing processes through systems like OpenAI's robotic hand represents more than just technological advancement. It represents a fundamental shift in how humans and machines can work together to solve complex problems and create value. As these systems become more sophisticated and widely deployed, they promise to unlock new levels of productivity, quality, and innovation that will define the future of manufacturing and, ultimately, the global economy. The revolution has begun, and its impact will be felt for generations to come.